Atomic models. Thomson atomic model. Sir J. Thomson was the first to propose a model of atom in 1898. According to him, atom is a sphere in which the mass and positive charge are evenly distributed. The electrons are embedded within this could vibrate about fixed equilibrium position. Rutherford model of atom. 1. Atom is spherical in shapes and mostly hollow. Second, positive charge and the whole mass of the atom is concentrated in a small region at the center called nucleus. 3. The electrons are present outside the nucleus and equal in number to the proton inside the nucleus. Fourth, just as the planets revolve around the sun, the electron revolves around the nucleus. Defects in Rutherford models. According to the laws of physics, any charged particle moving under the influence of opposite charge should lose energy continuously. Thus, electrons revolving around the nucleus shall also lose energy continuously. Come closer and closer to the nucleus in the spiral path and ultimately fall into the nucleus. Then the atom shall collapse due to the merging of the electron with the nucleus. 2. If the electron lose energy continuously, the atomic spectrum should have continuous band, but the atomic spectrum of the element are found to contain discrete lines. Atomic number. Moseley 1913 proved that total positive charge of the atom of an element is equal to its atomic number. Thus, number of protons in the atom of an element is equal to its atomic number Z. Atomic number Z equal to number of units of positive charge equal to number of protons. Mass number A. The mass number defined as the total number of protons and neutrons present in the nucleus of the atom. Wavelength lambda. The distance between any two similar points on the successive waves, that is, the distance between two successive crests or trough is called wavelength. Lambda. Wavelength is expressed in angstroms. Unit A Armstrong or nanometer. 1 Armstrong is equal to 10 raised to minus 10 meter. 1 nanometer is equal to 10 raised to minus 9 meter. Electromagnetic radiation responsible for the different color of the spectrum of the visible light have different wavelength. The visible light has wavelength range 3800 Armstrong to 7600 Armstrongs. The wavelength of a radiation is inversely proportional to its energy. Thus, radiation with the long wavelengths are associated with less energy and vice versa. E is inversely proportional to lambda. Frequency nu. The number of wave crust or trough that pass a given point is in a medium in 1 second is called frequency. The frequency of radiation is directly related to its energy. E is directly proportional to nu. Radiation of high frequency possesses high energy and vice versa. Wave number. Instead of frequency, a term called wave number is generally used. It is equal to reciprocal of wavelength in centimeter. Wave number is equal to 1 lambda. Centimeter unit is per centimeter. Velocity c. Velocity is defined as the distance traveled by the wave in 1 second. It is denoted by the letter c. Velocity is equal to frequency multiplied by wavelength. C is equal to wave nu lambda. Electromagnetic spectrums. The arrangement of electromagnetic radiation in order of their increasing or decreasing wave number is known as the electromagnetic spectrum. Its range of wavelength in the visible region lies between 3800 Armstrong to 7600 Armstrong approximately. Dispersion of light. Splitting of light into its various color by refractions through a prisms is called dispersions of light. If the sunlight is passed through a prism, it gets split into 7 colors: violet, indigo, blue, green, yellow, orange, red. This pattern is called spectrum. Spectrum is obtained with the help of an instrument called spectroscopes or spectrograph. Continuous spectrum. When this dispersed light is allowed to fall on a photographic plates, the color from the violet to reds are seen on the plate without any gaps between each other. This type of spreading of color is called continuous spectrum. Emissions or line spectrum. When light emitted by a gas or vapor subjected to high temperature is passed through a prism or a grating in a spectroscope, the spectra will have a sharp distance, well-defined lines and is called line spectrum. Atomic spectra. The line or Bell space groups of line found in the line spectrum are caused by gaseous atoms. Hence the spectra are also called atomic spectra. Band spectrum. Band spectrums will have continuous bands caused by molecule. This is called band spectrum or molecular spectrums. Also the band is made up of very closely spaced line. Atom produce line spectra while molecule produce band spectra. Quantum theory. When radiant energy falls on the surface of a body, a part of it is absorbed, a part is reflected, and the remaining part is transmitted. Thus, incident energy equal to absorbed energy plus reflected energy plus transmitted energy.